Today I'll show you how to solve this problem by using Excel goal sheet. I have already uploaded one video for this problem where I solved this problem by using MATLAB. Today I'll show you how to solve this problem by Excel. Now problem is here. In that problem it is saying that find the molar flow rates of all pieces out of an equilibrium from the reactor when the inlet values of nitrogen and hydrogen and ammonia are 1.13 and 0.2. The equilibrium constant is given, that is 0.05 at 589 Kelvin, and Kp expression is given. Kp is equal to mole fraction of ammonia divided by mole fraction of nitrogen to the power half, mole fraction of hydrogen to the power 3 by 2 into 1 by P. For the reaction written as half of nitrogen plus 3 by 2 hydrogen, so that will produce 1 mole of ammonia. Use 220 means 220 atm for the pressure. We have to solve this problem. So first use MATLAB, that I have already uploaded the videos for this problem. Now today I'll show you how to use Excel. So before that, now here let X mole of ammonia produced and reach equilibrium. So here reaction is given by half of nitrogen and 3 by 2 hydrogen, so that will produce 1 mole ammonia. So now we know from that reaction stoichiometry, so 1 mole of ammonia production required half mole of nitrogen and 3 by 2 moles of hydrogen. So now here we are considering X mole of ammonia produced and reached equilibrium. So how much moles of nitrogen and hydrogen is required for production of 1 mole of X mole of ammonia? So X mole of ammonia production required X by 2 mole of nitrogen and 3x by 2 mole of hydrogen. Now here in the table, so I am showing everything. So component is given, so nitrogen, hydrogen and ammonia. So inlet molar flow rate, so that is given 1.13 0.2, so that is 4.3, and then molar flow rate at equilibrium. So now X mole of ammonia actually produced, right? So for that at equilibrium, how much nitrogen is still remaining? So X by 2 is the consumption, so remaining amount is 1.1 minus X by 2. Now what will be the hydrogen amount? So that is 3 minus 3x by 2. From the stoichiometric equation we are getting that 3 minus 3x by 2. 3x by 2 is the consumption and X mole of ammonia produced. Now what will be the ammonia present at equilibrium? So that is 0.2 plus X. Now if we add all this, so the total mole will be 4.3 minus X. Now we can calculate mole fraction also. So individual mole by total mole. Individual mole of nitrogen is 1.1 minus X by 2 at equilibrium obviously. By total mole 4.3 by X. Similarly, if we do that, so we'll get hydrogen mole fraction, ammonia mole fraction, and the total mole is 1. Now here that Kp expression is given. So P is given, Kp is given. Now we have to put that ammonia mole fraction, nitrogen mole fraction. So we'll get that equation. So after plugging all these values, we'll get that, and expression Kp will be this one, this. And if we solve this problem, if we solve this after even put Kp value and P value, so finally we'll get that one nonlinear equation. And then if we solve the nonlinear equation, we'll get X. And after getting X, if we plug all this value of X, so molar flow rate at equilibrium we will get, and as well as mole fraction of all this component we will get. Now I'm going to solve by using Excel. So now I'm going to that Excel sheet. So this is the problem. Now first I'm writing here, so component ENT. So that is first one is nitrogen, then hydrogen, then ammonia. Then molar flow rate, inlet molar flow rate. So that is inlet molar flow rate is given 1.1 then 3, and then 0.2. So now what will be the total? So total will be total will be the sum of all three. Now, so here Kp value is given. Kp value is how much? 0.05, and P is also given. So that is 220 PATM. That is given. Now, so we are considering that let X mole ammonia NH3 produce. Let's say X is, let's say, so that we don't know that X is nothing but something 0.1. Let's say so after solving that we will get the actual things. So this is guess value. X is suppose 0.1. If X is equal to 0.1, so now what will be the molar flow rate at equilibrium? So molar flow rate at equilibrium, that we can get easily. So that will be, so 1.1 is that originally nitrogen inlet molar flow rate is already given. Now from that the stoichiometry, so that X mole ammonia production, X by 2 mole nitrogen is required. So that how much molar flow rate at equilibrium? So that will be 1.1 by X by 2. So that will be the molar flow rate at equilibrium of nitrogen. So what will be the hydrogen? So that will be 3 minus X 3x by 2. 3 because stoichiometry is 3 by 2. 3x by 2. You get that 2.85. And then ammonia. So that will be sum of this plus X. Now total will be this 4.2. Now what will be about the mole fraction? So mole fraction at equilibrium. Mole fraction at equilibrium will be, so that is total mole and individual mole. So that will be individual mole by total mole. Similarly, individual mole by total mole. Similarly, individual mole by total mole. If we add that, I hope it will 1. Okay, so means our calculation is okay. Now, so Kp value is there, so we have to make that equation. So equation we already got that equation. So that equation, so Kp into ATM, and then we have to that, or Kp, we can do that. So Kp into that ATM minus that all this mole fraction. Okay, mole fraction term. Now we can do that in the Excel. So now fx will be fx function of x. Okay. Fx will be f of x. F of x will be, so that is, we can take Kp into P. So Kp is here, okay, so equal to Kp into P, then minus ammonia mole fraction. So that will be ammonia mole fraction is here, divided by then mole fraction is here, then divided by, then mole fraction of nitrogen is here, to the power half, 0.5 we can write, then into, then mole fraction of hydrogen to the power 3 by 2. So divide 3 by 2 means 1.5. So if we do that, we'll get the Fx value. Now we are taking that X gas value. Okay, so X gas value we are taking that. So we can put some highlight, or we can put that, and based on that we got that Fx value. Ultimate our target Fx some X will be there, means root value will be there, means we have to calculate that. By Excel we have to calculate that root of this equation. Okay, after getting that, you automatically get all this value, or what will be the molar flow rate, mole fraction, everything. Now we will use goal seek. So for that, what we have to do, so for that we have to do is go to that data, then what if analysis, goal seek. In that goal seek, so this cell, okay, so this cell we have to set cell is G3, so 10.744, and that value will be 0, and by changing is this value. Now after doing that, if we do that, so we will see that molar flow rate at equilibrium, so that will be this amount. Nitrogen molar flow rate at equilibrium, so 0.3654, hydrogen is 0.79, and ammonia is 1.669, and mole fraction will be 0.129, 0.281 and 589. So exactly I think we solved by using MATLAB. So you can see here, so that is the value. You can see that, so that molar flow rate is 3654 of nitrogen molar flow rate is here, hydrogen molar flow rate is 0.7963, ammonia is 1.6691, okay, and mole fraction also 0.1291, 0.2813 and 0.5896. Now you can tally with that MATLAB also. So this is the MATLAB code. So that video I have already uploaded. Now I'll show you how to solve by using goal seek, Excel goal seek. That's it. Thank you.